Hi, I'm Russell, and this is Jacob, and this is our 158 final project in Max. And we built a augmented reality xylophone, as you see above us. And as you can see, it works very well, and hopefully you'll play with it and enjoy it just as much as we have. So now we're going to run through exactly how we made this.
Yeah.
Jacob.
So one of the first challenges in making this patch was figuring out how to detect motion. And so we found a cool package that someone made called cv.jit, and it had a lot of computer vision stuff. And so we looked around for a little bit, and we found one specific item that was really useful: the cv.jit.framesub. And what that did was it gave you a difference of 2 frames between consecutive frames. So that turned out to be really helpful. Now that we have an object that gives us the difference between 2 frames, we can just check those pixel values and see if they meet some threshold value for what is a change in video. And if so, and if it's on a note, we can tell Max to play that note. We can make an envelope that we're choosing. We kind of chose a bell type because we wanted to sound kind of like a xylophone.
And you can visualize that motion if you look up in this top corner right there. You can see the motion in my hand.
Yeah, and so right. And Russ, do you want to talk a little bit about how we drew how the actual,
yeah? So we use
done?
OpenGL to compute the graphics on the GPU, and they're actually being rendered real time. So we have this dynamic effect that when the note is played, we see that it actually changes opacity to be able to give you some visual feedback into as to whether the note's been played or not.
And so the first part of the project was definitely the minimum viable product was getting a xylophone to be up there and getting the notes to play when you hit the notes. The next thing we worked on was sending the frames to Google and to try to get an emotion recognized out of your face, and we would want to change the mappings of the notes to kind of reflect that emotion. Russell, do you want to talk a little bit about how the Google API was implemented and kind of some problems practicing with that?
Yeah, thank you, Jay. The Google API, which is actually the Google Vision API, was a big technical challenge for us, given the limitations of Macs using conventional software. So eventually, we settled on using Python script called from the shell package, and then using some fancy I/O methods, we were able to get the data sent to Google properly and get the response back. And so we can actually show you a live demo now because we're so excited about it. But first, we're going to talk about how it's on a Q metro every 3 seconds, and that's because we want to give time for network lag and also max lag and not crash anything. So we'd rather be safe than sorry. So I might have to make a ridiculous grin for 3 seconds to be able to show you. So, as you see, it just switched to Joy because he started smiling at my joke. So yeah, it clearly works. And the best part is once you set to Joy, it actually changes the notes. So we have some modulation. So now when we play, it's a little bit higher notes. And I think, do you want to talk about our multi-threading capacity and the parallelized?
Definitely, yeah. So we kind of set up the computation to run. We set up 8 little computations to run all at the same time. So we have different threads looking at different parts of the screen, and this allows us to play 2 notes at the same time. And have 2.
Well, actually, up to all the notes at the same time, theoretically.
Right. Theoretically, all the notes at the same time. So if we want to try 2 notes, it's a little hard to try to play them exactly the same time. But if you can you hear that's kind of 2 notes at the same time. That's right. So, and then of course you can also just mess around and just play all of them. And as you can see, the deltas are moving in the top right there. Now, one thing we noticed kind of with the deltas, we would do this in the morning, and then we would test this at night, and we would kind of get different values. And we realized what we needed was a way to change the sensitivity to motion. And so there's a built-in sensitivity,
which is this bar right to our right here.
Change it here. So if we make the sensitivity really, really high, Max is going to work a lot harder.
Then it's just
as soon as you move in touch, maybe if we move the computer a little bit, you can see all of them just immediately free and go on. However, we can also move it really, really low, and it makes it really hard to actually play a note, and you have to maybe move your elbow or move your hand to try to get something working. But yeah, that was about it for my
Yeah, and
project.
so we hope you have as much fun as we did playing with this musical instrument, and we'd love to get your feedback. Thank you.
Where desktop.